Okay, so we have SOHCAHTOA, and we're going to plot theta there. So writing this out, we get the sine of theta is opposite over hypotenuse. So its reciprocal is cosecant theta, would just be hypotenuse over opposite. And I would greatly appreciate if you would put your reciprocals either one above and below or beside so that, I can find them easily. Cosine theta is adjacent over hypotenuse. Secant theta is hypotenuse over adjacent. It's just the reciprocal. Tangent is TOA, opposite over adjacent. And cotangent is adjacent over opposite. Now I need to pause here a moment. On the quiz that we just took, I had students who wrote this down. What's wrong with that?
Sign of what?
It's the sign of what? And so what it tells me is that we actually don't have a good foundation here. It has to be the opposite of something and the hypotenuse of something. So this, and I did take off on your quiz when you get it back, hopefully tomorrow, you needed to say the sine of t, the sine of 7 pi over 4. It's from that angle, it's the opposite side over the hypotenuse. So, I'm not trying to nitpick you, but it has to be of an angle. That's what the right triangle trig is. It's of an angle that we're working with. So let's, try to be careful with that. All right, so these are your 6 trig functions. That's not new, right? We knew those. Then, in a 45-45 right triangle, go ahead and draw this triangle. If it's on the unit circle, the 2 sides are 1, and the hypotenuse is radical 2. So what we know is that the sine of 45 degrees is 1 over radical 2, which is radical 2 over 2. Now, the reason why I'm putting 1 over radical 2 is I'm doing forward thinking here, and I know for cosecant, I would rather flip 1 over radical 2 than flipping 2 over radical 2 and then having to rationalize, okay? Then for cosine 45 degrees, it's actually the same thing. And so secant 45 degrees is radical 2. Now, we've learned previously that tangent was sine over cosine, which we're going to need. But in the triangle, from 45 degrees, opposite over adjacent is 1. So what's going to be neat about this is as we continue to move forward in 4.3 and 4.4, we're still working with our unit circle. So if you still struggled a little bit, the good news is we're going to keep building a foundation. And you're going to end up with 3 different ways to figure out your trig values. You can use a triangle. I'm going to draw the chart, and you can use your unit circle. So whichever way seems to make the most sense to you, that's the way you want to do it. It does not matter to me. I will never say you have to do it this one way. I'm going to say evaluate it, and how you figure that out is up to you. All right, now, in this next group, we're going to do a 30-60 right triangle, and you guys, we're going to end up putting 12 things here, so write small. Across from the 30 would be 1, the hypotenuse is twice that, and then the long leg is radical 3. So we're going to do the 6 trig functions of 30 degrees, and then the 6 trig functions of 60 degrees. So write kind of small here. If I have sine of 30, sine, so, is 1 over 2. So cosecant 30 degrees is 2 over 1, or just 2. The cosine of 30 is radical 3 over 2. So secant 30 is the reciprocal, so it's 2 over radical 3, which I would rationalize to 2 radical 3 over 3. Tangent 30 would be 1 over radical 3, which is radical 3 over 3. But the reason why I wrote it first as 1 over radical 3, even though I know how to rationalize that mentally, I knew it would help me when I did my reciprocal. Okay? Now I'll switch colors, and let's repeat with 60 degrees. The sine of 60 is radical 3 over 2. Now you guys don't redo the work. Did you see in the previous set when I flipped this? I've already rationalized it, so don't, do the work again. I know rationalizing is going to be 2 radical 3 over 3. Cosine 60 is 1/2. So secant 60 is 2. Tangent of 60 is TOA, so it's opposite, which is radical 3 over 1, or just radical 3. Cotangent 60 is 1 over radical 3, or radical 3 over 3. Alright, because what's going to happen as we progress, I'm going to expect you to know, when I say what's the sine of 30, you should not have to be looking somewhere. You need to know sine 30 is 1/2, sine 60 is radical 3 over 2. Cosine 30, radical 3 over 2, cosine 60, 1/2. They need to become fast and natural, okay? You just know them. Alright, so, now worst case is you can always draw your triangles and figure them out, okay? But you might get frustrated with me as we move forward, and I'm assuming you're with me. So let's look at this exploration. I said, what is the sine of 30 degrees? Well, let's just look above. Sine of 30 is 1/2. And the cosine of 60 is 1/2. All right, that's interesting. The sine of 60 is radical 3 over 2. And the cosine of 30 degrees is radical 3 over 2. Huh. Now, I'm not sure that it's as clear as I would like to make this as to what's going on. Now, these are the same, right? Radical 2 over 2. So, I want to be a little bit more transparent here. And I want you to take out your calculators. Check your mode. Let's put it in degree mode. Somebody asked me this morning, they said, well, how do you know what mode to be in? If the angle has a degree symbol, you switch it to degrees. If there's no degree symbol, it's assumed radians and you switch to radians. Okay, that's how you know. So you turn your calculator on. I'm going to put it in degrees. And the sine of 10 degrees is 0.1736. The cosine of 80 is hey, those are the same, right? Now, I think it might be a little bit more clear. What's going on here? What do you notice about the relationship of the two angles? 90. Good job, okay? When you add them, 30 plus 60 is 90, okay? 60 plus 30 is 90, 45, 40 is 90, but 10 plus 80 is 90. So this is, and we're not going to do it with cotangent and tangent, because I think now we've got it. But those are called cofunctions. Sine and cosine are cofunctions. Tangent, cotangent are cofunctions. And secant, cosecant are cofunctions. Well, what we know is that complementary angles of cofunctions are congruent. Remember that now. Do you guys remember? I'm going to embarrass Scott. This will be live in infamy now. I embarrassed him second period. When he was in about 3rd grade, he used to read the Captain Underpants books. Does anybody watch Captain Underpants or read? And I used to love reading to my boys. They don't like me to read to them anymore, but I would always read to them at night, and they would be in different books. And I remember Scott was really into Captain Underpants books, and so every, like so many chapters would be like, remember that now, and so like that sticks in my head. That's silly. Silly but true. Now you can go embarrass Scott later today. What?
Your subscribers know the real you.
Okay. All right. Yeah. All right. So here we go. Fundamental trigonometric identities. All right, here we're going to get to the fun stuff.
You made all that stuff before, wasn't fun?
I know. Well, it was still fun, but we're going to get more
It's not
fun.
gonna be as fun.
This is more fun. All right, sine theta is equal to 1 over cosecant theta, and cosecant theta is 1 over sine theta. So what do you think we could say about cosine theta following this pattern? 1 over secant theta. Good job. And then secant theta is 1 over cosine theta. Because this is sometimes going to help us later in this section, and then a whole bunch in chapter 5. Then tangent theta is 1 over cotangent, and cotangent is 1 over tangent. Now we also know something about tangent and cotangent. Quotient means fraction. Well, we also know that tangent is sine theta over cosine theta. And we know cotangent is cosine theta over sine theta. All right, now, drum roll please. The Pythagorean identity is huge, 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 huge. We're going to use this a lot. Okay, I cannot emphasize this enough, and I'm going to develop it here. Okay, so do you remember on a unit circle, it's called a unit circle because the radius is 1, and if I go to some random point x comma y, I can drop a perpendicular. This is x and this is y, right? Well, that's a right triangle, and I know that x squared plus y squared equals 1 squared, or just 1. Now let's make a connection to what we've been doing. This is just very, very exciting. Okay, so that angle's theta. And what do you know about x comma y if I want to do something with respect to theta? How could you rename x comma y? Yeah, there we go. Isn't that cosine theta comma sine theta? Okay, the x is cosine and y is sine. So watch this. This is actually cosine squared theta plus sine squared theta equals 1. Now I need to make a little comment here to see if you remember this from last year in Algebra 2 trig. If I'm squaring a trig function, we write it like this, okay? But I want you to make sure you understand. When I'm putting that little 2 here, it really does mean cosine theta times cosine theta. Okay, it's not thetas or anything else going on. So this is my first Pythagorean identity. Sine squared theta plus cosine squared theta equals 1. And again, I need you to put like a huge stars all over this one. This one we use so much this year, and it comes up in AP Calculus. I'm like, remember Pythagorean identity? I'm like, oh yeah, okay. So now, there's actually 2 others. But, you know, you have to remember a lot. You have to keep a lot in your tool belt or in your head. And so, I personally don't memorize the other 2, but I figure them out when I need them. So watch what I'm going to do here. Off to the side, just beside this, and you're going to need room for one more, so make sure you're writing in a size appropriately. If I have sine squared theta plus cosine squared theta equals 1, watch what I can do. I mean, this is like some fancy math work. This is really cool business. If I divide by sine squared theta, I'm getting 1 plus, that's cotangent squared theta equals, what's 1 over sine squared theta equal to? Come here, come here. What is that? Cosecant. Yeah, cosecant squared theta. There's my second Pythagorean identity. Again, I don't memorize this, but I can figure it out. All right, now let's do the third one, okay? If I have sine squared theta plus cosine squared theta equals 1, what else could I do instead of dividing by sine squared theta? All right, brilliant. Let's do that. Great idea. Let's divide by cosine squared theta. All I can imagine is you guys are like listening to me on the weekends and like laughing at me. You guys all get together and say,
Hey
"Oh,
guys,
let's listen to her again." She's so crazy. All right. So I'm getting tangent squared theta plus 1 equals secant squared theta. So these are the 3 Pythagorean identities. And really, you don't have to memorize any of them because you can go back to your circle to come up with the first one. However, you almost can't avoid memorizing it because we're going to use it so much. So sine squared theta plus cosine squared theta equals 1 is your number 1. And I'll tell you, we're going to do things like verifying and simplifying trig identities and trigonometric expressions. We're going to be proving. I love that. That's always fun to prove them. This one, the one with cotangent squared, is not used very often. This one's pretty often. This one's a lot. Okay, so you will see that as we move through the chapters. Okay, so now let's use it. It says if theta is an acute angle such that cosine theta equals 0.3, then find the following. Well, let's pause here a moment. And, you know, you are in an honors pre-calculus class. This is honors, okay, to be a 5.0 class. And so one of the things that we need to be doing is really pausing and thinking through things. If it says theta is an acute angle, I need to stop and think about that. What does theta is an acute angle mean? Good job. It's an angle that's less than 90. On the unit circle, where is that? Quadrant 1. So that means sine, cosine, tangent are all positive there. Do you see how I'm processing and analyzing that? Okay, now I'm going to use my newfound Pythagorean identity. And I have sine squared theta plus cosine squared theta equals 1. And I know that cosine theta is 0.3. And so I'm taking cosine theta and I'm squaring it. Remember, that's what this notation means. Well, 0.3 times 0.3 is 0.09. And then I would subtract that from both sides. Now I'm going to have to go to my calculator now because I don't know the square root of 0.91 off the top of my head. So I'm getting 0.9539. Now notice, you would have gotten plus or minus, but because theta's an acute angle, I only have the positive value. Okay, I just did the square root of both sides to get sine theta. All right, now, and what I absolutely love about this and what gets me just so wound up is that we have so many tools in our tool belt. And to be able to really stop and think about these, what do I have? What do I know? How can I do that? When I can figure it out, I feel pretty good. Like I'm you know, a smart cookie here. So when I'm doing tangent, I know tangent is sine over cosine. Well, I have both of those. I have 0.9539 divided by 0.3. So if you don't have your calculators out, get them out and let's divide. And I'm getting 3.1798. Well, if I know tangent, what can I do to find cotangent? Don't you know it's 1 over tangent? Or could you just flip the fraction? Either way, both will work. So I got 0.3145. All right, now how will you find secant theta? What do you know about secant theta? It's 1 over cosine, right? So that's just 1 over 0.3, which is 3.3 repeating, I think. And then what do you know about cosecant theta? Isn't it 1 over sine theta? And I'm getting 1.0483. All right, now I'm going to show you on letter B a second way to do this. If I know tangent theta is 3, cotangent would just be 1 over 3. That's easy. The second method is you can use a triangle. I personally do it with the triangle than my trig stuff, my trig identities. If I know tangent is 3, that's 3 over 1. I can do Pythagorean theorem to do the hypotenuse. Well, then this is hypotenuse over adjacent because it's the reciprocal of cosine. So it's radical 10 over 1 or radical 10. I do not care which way you do it, whether you do it with a triangle or you do it with some of these Pythagorean identities. Either way works. You choose. All right, last thing we're going to do before the bell rings is example 3.
Pythagorean theorem.
You okay? Any other questions? You guys see what I did? All right, last thing is it says we want to evaluate, and we actually already know how to do this. Let's pull out the calculators. Remember, there's no secant button. But I know that secant is 1 divided by cosine. But I need to check my mode. Make sure I'm in degree mode because there's a degree symbol. So then I'm going to take 1 divided by cosine. It's 5 degrees, 40 minutes. And to get the seconds, remember that's alpha plus sign. And we did that with our programming last year, the quotes. So you should be getting 1.0049. And then let's do cotangent. That would be 1 divided by tangent, 11 degrees, 15 minutes. And I'm getting 5.0273. Now, can you think of any place where somebody might be using degrees, minutes, and seconds?
You said ships and stuff.
Ships, yeah, ships would be using it, navigation, things like that.